Okay, so the first video I made before it started to get really glitchy, I had done different compounds and enantiomers. But I wanted to do at least one of each of these, so I have a couple more here to get through. And these were all already done as well in class. And so the answers have been confirmed. But if there's anything that's unclear or doesn't look right, just like let me know. Okay. So the top one, I don't know if we should do it. I mean, we can. Uh, First thing I would do is to check if they're different, so I would number them. With bicyclic compounds, with numbering, you always start at the bridgeheads, and so let's do one, and then the biggest side or the one with a substituent, two, three, four. I think we could stop there. Same thing here. One, two, three, four, and we can stop there because we've already hit our substituents. And so the oxygen is a substituent on both carbons right here, the second carbon for each one. So now I can erase this. And now that I've confirmed that it's not different and not constitutional, I can go forward. So I'm going to write here, not different, and also not constitutional because they're both connected at the number two. Okay, so now the next thing is to check if they're the same. And to do that, you check their configurations. And so let's do two different colors for configuration. Let's do like a green and the next one will be a purple. Cool. So let's do green. Let's start. So we start at the chiral centers. There are two, since there are two bridgeheads. And so we can do, or actually, yeah, there are two. So we're going to start with the first one here. So I found the chiral center, and I'm going to number the priorities. My first carbon or priority, they're all carbons, like to the left, to the top, to the right, except for the fourth connection, it's a hydrogen. And we know hydrogen's number four. So my first carbon is going to be priority, the one connected to the oxygen. The second one will be the one that'll get me to this one the quickest. And so I think it's this one. And then the third one is eventually one day it'll get to the other side. And so this side will be three. The hydrogen is the fourth priority group, and we always want the fourth priority to be facing away from us. So since this is already facing away from us, we can trust this perspective and we can go one, two, three, one, two, three, like that. And that is clockwise, which is in our configuration. Okay, let's go to the same chiral center that's on this bridgehead, just across. And then let's number them. So we know there's going to be a hydrogen facing away, and we know that'll be our number four. Our first carbon, same thing here. And usually immediately just from looking at these, right? If you just pause and you look and you don't go through all of this, you can tell that these are enantiomers. You check R, and because this is an exact mirror image of this, you know it'll be the opposite configuration. So you know it'll be S. And same thing for down here. Whatever you get down here, you know it'll be the exact mirror image. So off the bat, just from looking at this, in the textbook, when you're looking at a definition of an enantiomer, it's a non-superimposable uh, molecule or compound that's like mirrored essentially, and this is it. So if we were to put like a mirror here, this would be the same reflection. But let's just go through all the rules like we usually do. I'm just going to go over the first two real quick just to confirm it. And so we have our one, second one would be up here, and then third one down here, clockwise, counterclockwise. So we can trust this. It's S because the hydrogen is facing away. Let's go to our second chiral center down here. Uh, we know there's a hydrogen that is facing towards us here. Uh, that okay. And then our first carbon is going to be to the left of us because it's the closest one to the oxygen. Second one will be up there again because that's the other closest one to oxygen, and the farthest one is here. 1, 2, 3 clockwise. However, if you look at this, one one way he did it in class was if it's 1, 2, 3 clockwise, but the hydrogen is facing us. Whoopsies. The hydrogen is facing us, then we assume counterclockwise. Uh, the other way to do it, aside from building a bicyclic compound, is to draw a person that's looking at it from here. So this person is almost across from us, and that's his laser vision. And he's looking at it from directly across from us. So when he's looking at it, he sees one on his right, he sees two on the top, and he sees three on his left. Um, and so it's counterclockwise to that person as well. This is what it looks like for them. And this is a mirror, so we know it'll be R. So R opposite S, S opposite R. We now can confirm that these are enantiomers. Just in case you still want to check your work, do all that stuff. But usually from the get-go, just from looking at these and confirming the connections are all there, you can automatically tell it's a mirror reflection of itself. That's non-superimposable. Okay, let's go down to these. All right, so let's do P3B. I'm gonna do a different color. I think my first thing I always do is I number the carbons, and then I check the ones on the other side just to make sure off the bat we see that there's an OH, there's an OH, there's a BR, there's a BR. We know that these are not different because it also has an alkene, and it's also a hexane, or I guess hexene. And so we can now number them. Let's start with OH. We go this way, 2, 3. I'm gonna stop here at the substituent. And so now that I have 1 on OH and 3 on BR, let's do the same thing here. Well, actually, let's go all the way to the alkene, 4. Okay, same thing here. 1, let's go towards the bromine, 2, 3, 4. Okay. 1 has a 1 OH, 3 has bromine, 4 has the alkene, or the double bond. So we also know that they're not constitutional because they have the same connectivity. Constitutional. I'm not gonna write out the whole thing. And now we check if they're the same. How do we do that? We check for R and S configuration. And so let's get to it. Get green again. Let's check our first chiral center. And we know this is a chiral center because if you go this way, it hits a bromine first before the double bond. If you go this way, it hits the double bond first before the bromine. It's not symmetrical. And there's a hydrogen out here facing the opposite direction from us. That's our number 4. Our 1 will be the OH. Our number 2 will be, we can actually get rid of these numberings. That was more so to check the first two things. Our number 2 priority will be the carbon that goes towards the bromine because these two are the same. They're both CHH, CHH. This one's our next one. This one's CBr, and whatnot. And then this one's just going to be like CCH. And so this one will be our second, and then this one will be our third. So 1, 2, 3, that is clockwise. That's an R configuration. And we can trust this perspective because hydrogen is exactly where it's supposed to be, the fourth group pointing away from us. So let's go ahead and check the same chiral center on this molecule. The OH is facing away from us, but in priority, it is still number 1. Our second one will be the carbon that's facing towards the bromine, and the third one will be the carbon that's towards the double bond that'll eventually get to the bromine. And then our fourth, since OH is pointing away from us, that means hydrogen is pointing towards us. Okay. And that's our number 4. However, we cannot have our fourth priority group facing us. Fourth priority has to always be facing away from us. And then a couple of ways you can do this is you can just look at what conformation you have as is, 1, 2, 3. That's counterclockwise. You know it has to be flipped, so you could do it the opposite, clockwise, which would be our configuration. Or you can draw a person that's same way as we did up there, staring directly at us. because that's the only way the hydrogen will be away from him, uh, and or away from us is through his perspective, and he also sees it in a clockwise way. So what he's seeing when he's looking at it, he's seeing the three on top still, but on his left, this is his left hand, he's seeing a 2, and on his right, he's seeing a 1. So he's seeing it like this, clockwise. Um, so this is R. So far we have our R, and so far we have our R. Let's go ahead and do our second chiral center. This is our second chiral center since it has 4 distinct groups connecting to it. Our fourth group here is a hydrogen that is facing towards us. Let's actually make it easier and put it actually towards us on the paper. Okay, so let's do bromine as number 1, the carbon facing the OH group as number 2, carbon going to the OH group eventually one day, facing that way, number 3. So 1, 2, 3. This is left counterclockwise, so S configuration, but we have hydrogen. Whoopsies, I was afraid to leave it facing towards us. So this can't be right. So you can assume that S is wrong and do R, or you can draw a person that's facing the hydrogen that's facing away from us. Or the other way, which is you switch out the fourth priority group with whatever number has a wedge, which is 1. And then you give this 4 to here. And then the next 2 will just switch by default. And this is 1, 2, 3. We have clockwise, which is also R. Yeah. Yeah. And then we have the same chiral center here. Let's quickly label our priorities. Bromine as number 1, carbon facing the OH as number 2. The carbon eventually going to get to the OH one day when it goes fully around is number 3. And then we have a hydrogen facing away from us since as our fourth priority, since bromine's facing towards us. So this is a perspective we can trust because it already has a hydrogen facing away from us. This looks crazy. Hold on, let me just fix it. Okay, this looks a little better. 1, 2, 3. This is also clockwise, which is R. So look at that. R, 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 R. This is actually the same compound. We don't need to compare any further. We can go ahead and just write same. One day I will get this right. We can just go ahead and write same compound. Okay. So this is a little rhythm I've started to pick up, is just how I'm gonna compare and where I'm gonna start. I don't know how it's been working for other people or how other people attack or tackle these problems, but that's how I've been doing it. Let's do this third one on the page really quickly. Let's see. This yellow, yes. First thing I like to do is label my carbons. And so this is a chair conformation. It's also a hexane. It's the same thing as this, except it's in a chair conformation from the side. This is how we would see it. So we have our chlorine number 1, ethyl group number 2, and we have a CH3 or methyl group number 3. Actually, this is 3. This is 4. And then you can continue going around if you want. I'm going to go back to the chlorine at the top, which is here, which is number 1. I have a methyl group number 2, 3, 4. So right off the bat, they're not different because they're made up of the same molecules. The same 3 here are the same 3 you're going to find here. And so I can write that they're not different, but I've noticed something, and I don't know if you've also caught it. Our number 1 on both of them are chlorine. However, our number 2 on the first molecule is an ethyl group, and our number 2 on the second one is a methyl group. And then our number 4 here is ethyl, and our number 4 here is methyl. So they've been swapped. They're not the same on both. So that means they're not different, but they do have different connectivity. So we can write this is constitutional, and we do not need to compare any further. Constitutional compounds. Okay. And so we did these three. So I said I wanted to do one of each. We have enantiomers. Okay, let's do a final one right here. Okay, so this one's a tricky one because it has a Newman projection here. This one's also a hard one for me too, so let's do it together. So let's check first if they're different. So let's find our chiral centers. There's one here, and actually I want to make them different colors because this will help us in the long run. And then the other one will have purple. Okay, and then our other chiral center. So let's just check really quickly if it has the same. This has methyl CH3O, a carbon connected to CN, and we're going to assume a hydrogen. So let's check. We have a methyl CH3O, hydrogen, and then the carbon connected in the middle. Nice. So far, this first chiral center is matched up here. Let's go to the second chiral center. We have CN. I think this is cyanide, and then connected to the carbons connected to OCH3, and then a hydrogen, and then the center CN, CH3O, hydrogen, and the connection in the middle. Nice. So far these all match up. Both of these chiral centers match up, and their connections match up. And so we can write that these are not different, and they are not constitutional because they are all connected to the same chiral center. Um, okay. Now we want to check if they're the same by checking their R and S configurations. And this is how we check if they're the same. So let's go ahead and start numbering our priorities. So on this carbon here, our number one priority here will be the oxygen. Our second priority will be the carbon that's connected to the CN, which is the middle carbon. We're going to do it there. And then our third priority is the methyl group. And then final priority or last priority is facing away from us since we already have something facing towards us. And that's the hydrogen, and that's group 4. So it's facing away from us. So we know our perspective is correct as is. So 1, 2, 3. This is clockwise, which is an R configuration. And then we can go ahead and do this one here. Let's do our oxygen as number 1. Our center, remember our center carbon, this is the one that's connected to the back carbon. We're looking at it now like from front to back. And so our center is 2, and then our methyl group was 3, and our hydrogen was our fourth priority. So this is where it gets tricky because when we're looking at this compound, it is facing towards us. So far, all of these 3 dashes on this peace sign are facing towards us. The center is facing away from us. So our hydrogen, our fourth group priority should be the one facing away from us. So now we have to look at this from a different perspective. This is the part where you can turn your paper, draw a person, or come in already with this setup on your kit. And so let's look at it first from what we can see. We see 1, 2, 3. So it looks like counterclockwise S configuration. Not sure if we can trust that, but let's draw our person, right? This person has yet to fail me every time I draw his head bigger because this will maybe help me. Maybe let's put a smile on him. Help me see what he is seeing. Okay, so he's looking at this where the 4 or the fourth priority or the hydrogen is facing away from him. Okay, now let's see what he sees on his bottom left. His bottom left, I'm going to write it on our left. His bottom left, he sees a 3. And then on his top, he sees a 1. And to like, kind of like his middle, he sees a 2. Like that. Oops, that's an ugly 2. 2. So he is seeing it go clockwise. So I'm going to trust what he sees because the hydrogen is facing away from him. So our first configuration here is also clockwise. So it's our configuration, right? Okay. Nice. Okay. And so and now I want to come here I took a second to set up my 3D butane so we can use it for reference when we look at the Newman projections, or should we want to look at it from this way? And so since, so let's do our chiral center. Let's circle our chiral center. I think I erased it accidentally. Um, and let's do priorities. Uh, this is going to be number one, our oxygen, because it has the biggest atomic number from the others. And then carbon versus carbon. Second carbon is connected to an oxygen. This carbon is connected to a nitrogen. And so this middle one will be two, where it's connected, since that's next in priority. And then three will be the one connected to nitrogen. And then because we have a group already facing away from us, we know that our hydrogen is going to be wedged, facing towards us here. Sit this way, since there's more space. Okay. Okay. And that's our fourth priority group. Okay, so right off the bat, we know our fourth priority group should never be facing us. It should always be in the dashed position or facing away from us. And so if we look at it and see what the confirmation is, it looks like 1, 2, 3 counterclockwise. That's an S configuration, but we know that's not right. We know that the hydrogen should be facing away from us. So if we flip that configuration, it would be an R configuration. So you could do it that way, where just you assume because it's not S, it has to be R because these need to be switched. Or you can draw someone looking at it from the perspective uh, where hydrogen is facing away from them. So maybe someone over here looking at it from this perspective. I draw a very tiny body, very big head. And then what they see on their left is a 1. What they see on their right is a 2. And then on the bottom there, they see the 3. So what they see is clockwise R, right? That's the other way. The second way is telling us R as well. Now let's try our final way, which is just switching whatever dashed item or number you have, switch it with the hydrogen so that hydrogen can be dashed. And so let's say number 3 here is dashed. We'll cross out 3. We'll give 3 to hydrogen, and we'll just give this 4 to CN. Even though these would also actually be switched. And then we cross out our 4, we cross out our 3. Whoopsies, I meant to say give this 4 to CN. And then the other 2 remaining, you just switch those. And let's do 2. Let's do 1. 1, 2, 3. This is also telling us clockwise. So we just checked it 3 different ways, and all 3 ways said it would be clockwise. And so we can trust that the second configuration is R. And then the fourth way, if you have a model, build it and turn it and try to see it from that perspective as well. Although that might be a little bit more difficult. Okay, let's check our chiral center on the right compound. Okay, so same thing. We're looking at the back ones. So whichever ones are not here in this circle are our back ones. Our oxygen will be number 1. Our center is the carbon, which will be number 2 because it's connected to the oxygen here. Our 3 is this carbon connected to nitrogen. And then our 4 is the hydrogen. Okay. So it looks like 1, 2, 3 counterclockwise. The 4 is technically facing away from us because it's in the back. Let's see. Yeah, because it's in the back, all the ones in the back of this Newman projection are facing away. So 4 is already facing away. In that case, this would be 1, 2, 3 counterclockwise. And so that would be an S configuration. Okay, so we have R, that's the same. R, S, that's opposite. So we know they're not enantiomers and they're not the same compound. So these are just diastereomers. Remember, everything else is just a diastereomer. Okay, I'll put it up here. Okay.